The F-35's engine was failing at 30,000 feet, and their top specialist couldn't diagnose the problem. Mission abort seemed inevitable until the woman they thought was just a secretary walked over to the diagnostic screen. What she said next left the Air Force mechanic speechless. "It's a compressor blade resonance issue. I designed these engines. From which city in the world are you watching this video today?" If this story resonates with you, consider subscribing for more tales of unrecognized heroes. The fluorescent lights in Hangar 7 at Edwards Air Force Base cast harsh shadows across the polished concrete floor as Technical Sergeant Marcus Rodriguez stared at the diagnostic screen in disbelief. The data streaming from the F-35 Lightning II's Pratt & Whitney F-35 engine made no sense according to everything he knew about aircraft propulsion systems. "Run the diagnostic again," he told Airman First Class Jennifer Kim, though they both knew the results wouldn't change. They had run the same test sequence 12 times in the past 4 hours, each producing identical results that defied explanation. At her desk in the corner of the maintenance bay, Maria Santos continued typing repair schedules and work orders with the same methodical precision she had demonstrated every day for the past 5 years. The rhythmic clicking of her keyboard provided a constant background soundtrack to the controlled chaos of aircraft maintenance operations. To the mechanics and technicians who worked around her, she was simply part of the infrastructure, as essential and unremarkable as the tool cabinets and diagnostic equipment. Maria wore the same conservative business attire every day. Navy blue slacks, white blouse, and sensible shoes that allowed her to move efficiently through the hangar without calling attention to herself. Her dark hair was pulled back in a simple bun, and her workspace was organized with the kind of precision that suggested an engineering mindset, though no one had ever bothered to ask about her background. The F-35 that dominated the center of Hangar 7 represented the pinnacle of modern aviation technology, a fifth-generation stealth fighter capable of supersonic speeds and equipped with the most advanced avionics systems ever installed in a military aircraft. But for the past 18 hours, it had been grounded with an engine anomaly that had stumped the base's most experienced maintenance personnel. Sergeant Rodriguez, called Master Sergeant Diana Foster from across the hangar, her voice carrying the authority of 20 years in aircraft maintenance. "What's the status on the engine diagnostics?" Rodriguez looked up from his screen, frustration evident in his expression. "Ma'am, we're showing intermittent power fluctuations in the high-pressure compressor section, but all individual components are testing within normal parameters. It's like the engine is sick, but we can't find anything wrong with it." Foster approached the diagnostic station, her trained eye scanning the data with the expertise that had made her one of the most respected maintenance supervisors in the Air Force. At 45, she had worked on everything from legacy F-16s to the newest stealth technology, but the F-35's complexity sometimes challenged even her extensive experience. "Power fluctuations could indicate bearing wear," Foster suggested, though her tone lacked conviction. "Have you checked the high-pressure spool alignment?" "First thing we checked," Kim replied. "Alignment is perfect, bearings show minimal wear, oil analysis is clean. By every metric we have, this engine should be running flawlessly." The implications of the mysterious failure extended far beyond Hangar 7. The F-35 was scheduled for a critical test flight that would validate new software updates for the aircraft's sensor fusion system. Delays in the program had already cost hundreds of millions of dollars, and congressional oversight committees were demanding explanations for every setback. Colonel James Mitchell, the base commander, entered the hangar with the measured stride of someone carrying significant responsibility. His presence immediately elevated the tension level as mechanics and technicians straightened their postures and focused more intently on their work. "Foster, I need a realistic timeline for getting this aircraft back in service," Mitchell said without preamble. "Washington is asking questions I can't answer." "Sir, we're dealing with an unprecedented diagnostic challenge," Foster replied. "The engine is showing symptoms we've never encountered, and standard troubleshooting procedures aren't yielding results." Mitchell studied the diagnostic displays with the focused attention of someone who understood both technical complexity and political necessity. "What are our options?" "We could replace the entire engine," Rodriguez suggested. "That would guarantee resolution, but it would require a minimum of 72 hours and cost approximately $40 million. Or we could continue diagnostics until we identify the specific failure mode," Foster added. "But that could take days or weeks, assuming we eventually find the problem." Colonel Mitchell's expression showed the strain of balancing operational requirements with resource constraints. The F-35 program was under intense scrutiny, and every delay provided ammunition for critics who questioned the aircraft's reliability and cost-effectiveness. "There has to be a third option," Mitchell said, though his tone suggested limited optimism. From her desk across the hangar, Maria Santos continued processing paperwork while unconsciously monitoring the conversation. 5 years of working in the maintenance environment had given her comprehensive understanding of the challenges and pressures that defined military aviation operations. She had watched countless diagnostic sessions, absorbed technical discussions, and developed familiarity with aircraft systems that went far beyond her official responsibilities. As the discussion continued, Maria found herself studying the diagnostic data from her position across the hangar. The pattern of power fluctuations displayed on the screen was familiar, triggering memories from a professional life she had deliberately left behind. The symptoms were consistent with a specific failure mode she had encountered during her previous career, but one that wouldn't be apparent to mechanics who hadn't been involved in the engine's original design. "Run a frequency analysis on the power fluctuations," she heard Rodriguez say to Kim. "Maybe we can identify a pattern that points to the root cause." Maria watched as Kim input commands that would analyze the oscillation patterns in the engine's power output. The resulting data would show frequency characteristics, but without understanding the engine's design tolerances for harmonic resonance, the information would be meaningless. "The fluctuations are occurring at 24 to 7 Hz, Kim reported after completing the analysis. "Does that frequency correlate with any known failure modes?" Foster shook her head. "Not according to our maintenance manuals. The frequency doesn't match any of the documented failure signatures." Colonel Mitchell checked his watch, clearly calculating the political cost of continued delay. "I need options, people. This aircraft represents $1 billion investment, and we can't afford to have it sitting in a hangar indefinitely." That's when Maria Santos made a decision that would fundamentally alter her carefully constructed anonymity. She stood from her desk and walked across the hangar toward the diagnostic station, her movement deliberate but unhurried. The mechanics were so focused on their data analysis that they didn't notice her approach until she was standing directly behind Rodriguez. "Excuse me," she said quietly, her voice barely carrying over the ambient noise of the hangar. "I'm sorry to interrupt, but I think I might know what's causing your problem." All eyes turned toward Maria with expressions ranging from surprise to confusion. For 5 years she had been a background presence in their professional environment, someone who scheduled appointments and processed paperwork but never participated in technical discussions. Her sudden involvement in their diagnostic challenge was as unexpected as if one of the tool cabinets had offered engineering advice. Rodriguez was the first to respond. "Ma'am, this is a pretty complex technical issue. We appreciate the offer, but it's a compressor blade resonance issue." Maria interrupted gently. "The fluctuations at 2047 Hz indicate harmonic resonance in the high-pressure compressor section. Specifically, the 7th stage rotor blades are vibrating at their natural frequency due to aerodynamic excitation." The hangar fell silent except for the constant hum of ventilation systems and distant aircraft operation. Foster, Rodriguez, Kim and Colonel Mitchell stared at Maria as if she had just spoken in a foreign language, though every word she had used was technically accurate and precisely relevant to their problem. "How could you possibly know that?" Foster asked, her voice carrying a mixture of skepticism and desperate hope. Maria took a deep breath, knowing that her next words would shatter the anonymity she had carefully maintained for 5 years. "Because I designed these engines. I spent 15 years with Pratt & Whitney developing the F-35 Thornton Prolonge." The revelation hit the maintenance team like a physical force. Colonel Mitchell stepped closer, his expression shifting from frustration to intense curiosity. "You're an aerospace engineer," was Maria corrected. "I left the industry 5 years ago and took this position, but I was the lead engineer for the compressor section development program. I know these engines better than anyone else on this base." Rodriguez looked from Maria to the diagnostic screen and back again, trying to reconcile the quiet administrative assistant with someone claiming intimate knowledge of the most advanced fighter engine ever built. "Ma'am, if what you're saying is true, why didn't you mention this before?" "Because I'm not an engineer anymore," Maria replied simply. "I'm administrative support. Those are different worlds." Foster studied Maria's face with the intensity of someone evaluating a potentially life-changing claim. "Can you prove your credentials?" Maria returned to her desk and retrieved a folder from a locked drawer that none of the maintenance personnel had ever seen her open. Inside were documents that told the story of a distinguished aerospace engineering career. Patents for turbine blade designs, recognition awards from Pratt & Whitney, technical papers published in propulsion engineering journals, and photographs from engine testing facility. Colonel Mitchell examined the documents with growing amazement. "According to this, you hold 17 patents related to turbine engine design, including 3 specifically for the F-35 compressor section." "That's correct, sir," Maria confirmed. "And you've been scheduling our repair appointments for 5 years while we've struggled with engine problems you could have solved immediately?" Foster asked, her tone carrying disbelief rather than accusation. "I wasn't asked to solve engine problems," Maria replied. "I was hired to provide administrative support, which is what I've been doing." Kim looked up from the diagnostic screen where she had been studying the frequency analysis. Ma'am, if you know what's causing this problem, can you tell us how to fix it? Maria approached the diagnostic station and studied the data with the focused intensity of someone seeing familiar information through expert eyes. The patterns that had mystified the maintenance team were immediately clear to her, like reading a language she had helped create. The resonance is being triggered by a specific combination of flight conditions, she explained, pointing to relevant data on the screen. When the engine operates at 78% power with inlet temperatures above 85 degrees Fahrenheit, the aerodynamic forces on the 7th stage compressor blades reach their natural frequency. Rodriguez followed her explanation with growing comprehension. And that causes the power fluctuations we're seeing? Exactly. The blade vibration creates momentary disruptions in airflow, which manifests as power fluctuations. It's not dangerous, but it degrades engine efficiency and could lead to premature wear if left uncorrected. Colonel Mitchell leaned forward with intense interest. How do we fix it? Software modification. Maria replied without hesitation. The engine control unit needs updated parameters that prevent operation in the resonance. Instead of maintaining constant power at 78%, the system should automatically adjust to 77% or 79% when inlet temperatures exceed the threshold. Foster exchanged glances with Rodriguez, both recognizing the elegance of a solution that addressed the root cause rather than treating symptoms. That sounds like it would work, but we don't have authorization to modify engine control software. I can provide the specific code modifications, Maria offered. The changes are minor, but they require understanding of the engine's control architecture that most maintenance personnel wouldn't have. Colonel Mitchell's expression showed the calculation of someone weighing operational necessity against regulatory compliance. Ms. Santos, are you authorized to make modifications to F-35 engine control systems? Technically no, Maria admitted. My security clearances expired when I left Pratt & Whitney, but the modifications I'm suggesting are well within the parameters of routine software updates that field maintenance units perform regularly. Kim looked up from her computer where she had been researching engine control procedure. Sir, according to the maintenance manual, we are authorized to implement software patches for known performance issues, provided they're documented and approved by qualified personnel. And Ms. Santos is definitely qualified personnel, Foster added, studying the credentials Maria had provided. Colonel Mitchell made a command decision that would be reviewed and justified in multiple reports, but felt absolutely necessary given the circumstances. Ms. Santos, I'm authorizing you to develop the software modifications needed to resolve this engine issue. How long will it take? Maria considered the complexity of the required changes, factoring in her familiarity with the engine control architecture and the need to test modifications before implementation. 2 hours to write and validate the code, 30 minutes to implement, 15 minutes to test. We could have this aircraft flight ready before the end of the day. Outstanding, Mitchell replied. Foster, provide Ms. Santos with whatever resources she needs. This is now the highest priority maintenance action on the base. As Maria began working on the software modifications, word of her unexpected expertise spread rapidly through the maintenance community. Mechanics and technicians who had barely acknowledged her existence for 5 years now gathered around her workstation, watching with fascination as she navigated engine control systems with the confidence of someone who had helped design them. How did you end up working here as administrative support? Rodriguez asked as Maria typed code with impressive speed and precision. Sometimes people need a change, Maria replied, not looking up from her screen. The aerospace industry can be demanding, and I wanted something with more predictable hours and less pressure. But didn't you miss the technical work? Kim inquired. This seems like it would be much more interesting than scheduling appointments. Maria paused her typing for a moment, considering the question with obvious thoughtfulness. I missed parts of it, but there's value in all kinds of work. Keeping the administrative side running smoothly is just as important as solving technical problems. Foster, who had been watching Maria's work with professional interest, shook her head in amazement. 5 years? You've been here 5 years while we've struggled with engine issues you could have solved in hours. Different problems require different solutions, Maria replied. Most of the engine issues you've dealt with were routine maintenance problems that didn't require design-level knowledge. This resonance issue is unusual. It only manifests under very specific conditions. As Maria completed the software modifications, she walked the maintenance team through every aspect of the changes she was implementing. Her explanations were clear, technically sophisticated, and demonstrated comprehensive understanding of both the engine's design principles and its operational requirements. The beauty of this solution, she explained as she prepared to upload the modified software, is that it prevents the problem without affecting normal operation. The engine will still deliver full power when needed,
but it will automatically avoid the specific conditions that trigger resin. Colonel Mitchell observed the final stages of the software implementation with barely contained amazement. Miss Santos, this is extraordinary work. Have you considered returning to aerospace engineering? I've been happy in my current role, Maria replied diplomatically. But this is rewarding. The engine test that followed was anticlimactic in the best possible way. The modified software performed exactly as Maria had predicted, eliminating the power fluctuations while maintaining optimal engine performance across all operational parameters. What had been an unsolvable problem for the maintenance team became a routine software update under Maria's guidance. Test complete, Rodriguez announced, reviewing the final diagnostic data. All parameters nominal, no fluctuations detected across the entire operational envelope. Foster looked at Maria with newfound respect. Outstanding work. This aircraft is ready for its test flight. As the immediate crisis resolved and normal maintenance operations resumed, Maria found herself facing questions and attention she hadn't experienced since leaving the aerospace industry. Mechanics sought her advice on technical issues. Supervisors consulted her on complex problems, and word of her expertise reached maintenance units across the base. Ma'am, Kim approached her the following day. We've got another F-35 showing unusual vibration signature. Would you be willing to take a look? Maria considered the request, feeling the familiar pull of technical challenges that had defined her previous career. Send me the diagnostic data. I'll review it when I finish processing today's work order. Colonel Mitchell summoned Maria to his office 3 days after the engine problem resolution, her personnel file open on his desk alongside a formal request that would change her official role at Edwards Air Force Base. Santos, he began, I've received authorization to offer you a position as a civilian technical consultant for aircraft maintenance operations. The role would combine your administrative responsibilities with technical support for complex problems. The offer represented a return to the world Maria had deliberately left behind, but on terms that would allow her to maintain the work-life balance she had sought by taking the administrative position. What would that involve specifically? Continued administrative support as your primary responsibility, Mitchell explained, with additional duties providing technical consultation when needed. Essentially, you'd be doing what you did this week, solving problems that stump our regular maintenance personnel. Maria considered the proposal carefully. 5 years of administrative work had provided stability and routine, but the events of the past week had reminded her of the satisfaction that came from applying her expertise to meaningful problems. I'd be interested, she said finally. But I want to maintain my current administrative duties. I've found value in that work, and I think it gives me perspective that pure technical roles don't provide. Mitchell smiled. I was hoping you'd say that. Sometimes the best technical advice comes from people who understand the broader operational context. 6 months later, Maria Santos had become an integral part of Edwards Air Force Base's maintenance operation. She continued to schedule appointments and process work orders with the same efficiency she had always demonstrated, but she also provided technical consultation that had prevented millions of dollars in unnecessary repairs and aircraft. Her desk remained in the same corner of Hangar 7, but her relationship with the maintenance community had transformed completely. Mechanics sought her advice on complex problems. Her recommendations influenced procurement decisions for spare parts and diagnostic equipment, and her name appeared on technical reports that reached the highest levels of Air Force leadership. The interesting thing, she often told visitors who came to learn about her unconventional career path, is that the administrative work made me a better engineer. Understanding the operational side of maintenance, the scheduling pressures, resource constraints, and human factors, gives you perspective on technical problems that pure engineering education doesn't provide. The F-35 that had started everything continued flying test missions with flawless engine performance. The software modifications Maria had developed were eventually incorporated into the standard maintenance procedures for all F-35 engines, preventing similar problems across the entire fleet. But perhaps most importantly, Maria had demonstrated that expertise can remain valuable even when it's not being actively utilized. Her 5 years of apparent career regression had actually been 5 years of gaining perspective that made her technical knowledge more applicable and her solutions more practical. The mechanics in Hangar 7 learned to appreciate both versions of Maria Santos, the efficient administrative assistant who kept their operations running smoothly, and the brilliant aerospace engineer who could solve problems they couldn't understand. Both roles were essential, and both contributed to their mission's success. Sometimes, Maria reflected as she processed work orders while simultaneously reviewing engine diagnostic data from 3 different aircraft. The most important thing about expertise isn't using it constantly. It's knowing when to apply it and having the patience to wait for the right moment. The secretary who designed fighter jets had proven that career changes don't eliminate capabilities, they just redirect them. And sometimes the person scheduling your appointment knows more about your technical problems than anyone else in the building. The key is creating an environment where that knowledge can surface when it's needed most. As the sun set over Edwards Air Force Base, casting long shadows across Hangar 7, Maria Santos continued her work with the quiet satisfaction of someone who had found the perfect balance between expertise and humility, between technical achievement and practical contribution. The fluorescent lights still hummed overhead, the diagnostic screens still displayed complex data, and the most advanced fighter jets in the world still required careful maintenance. But now, everyone knew that the woman processing their work orders had helped design the very engines they were trying to understand, and that knowledge made everyone's job a little easier, and a lot more interesting.